Let's go ahead and take a look at how to compare two means using a hypothesis test of two means. Now, when we compare two means, we can do it two ways. We can actually directly compare them, which we see in the blue. We can say one proportion is equal to another, or one is greater than, right? Or we can say a mean is equal to, or another mean, or it's not equal to, as you see in these two examples in blue. Or in red, we can compare to see if their difference is equal to zero, which is similar to what we do in a confidence interval. We check to see if zero is contained. So these are two equivalent ways of writing the same statements, the same null hypothesis and alternative hypothesis. So keep that in mind. The Artostat uses the red version when you see the notation, but they both mean the same thing. We're comparing two means, we're just doing it mathematically different. So take a pause if you need to and look at that. It's simple algebra where you subtract, move one to the other side and then set it equal to zero. So that's what we're comparing really. If the difference is equal to zero, that means there's no difference. Using that similar scenario of using this example, let's take a look at SAT students and scores of an English only group, um, and then we have the another language group, people only know English, and then students who know another language, and comparing those two groups and finding out if their SAT scores are different based on this very large sample we have here. It's a very large sample. Um, you're going to see we're saying English only, the difference between English only and another language group is zero, and we want to check to see is there evidence of a difference between them, so that's not equals. If you would have said, is there evidence of one group being greater than or less than, then we would have used an inequality, the less than or greater than symbol. This is a two-sided test because the not equals, or two tails, another way to think about it. Two sample t-test, that's the procedure. Using an alpha level of 0.01, we would use the Artostat to calculate those values, get a test statistic, a very big one. Remember, the test statistic is a way of measuring how far is the sample data from the stated proportion. In this case, we're saying how far are those two um, how far are those two apart, those two values, considering the data? That's what we're looking at. So in the Artostat, we'll compare two groups, compare two means. I'll enter in the data. We're going to be, we have the summary statistics. After all the data is entered in, SAT scores, English only, another language, you have all the data. We're doing a significance test, two-sided, right, versus less than or greater than. That's our two-tailed. Get the data, and we're looking to see, is there a difference, right? Now, we know there is a difference based on the sample data, but we want to make an inference around the population. Do we have enough evidence to say, and it looks like a very big test statistic, t-value, and then you get a very low probability. So what's the probability of observing data like this if both of them, if there was no difference between those groups? And so because now we have this very low p-value, we can go ahead and make conclusions. We go ahead and look at, since the p-value is less than alpha, it was very small, right? We reject the null hypothesis. We reject that there is no difference, that the difference equals zero, which means no difference. There is sufficiency there. There is sufficient evidence to conclude that there is a difference between the two groups. And that's how we do it. We would have to do a fifth step in this case. Was it random? We don't know. It doesn't say anything about being random. Again, it's just a problem situation. Is the sample size large enough? For sure, but I don't know if it's less than 5% of the population. That's a large sample. So we get kind of stuck in reality of how to view this. We can make a conclusion, but then we have to uh, um, come to our conclusions very carefully or make statements like that given that we didn't meet all the conditions here. Now, we could go back to doing another example here, which is completed. This is with data. When you have the data, this was the data we've done in our previous example. So I already have the summary statistics that we got from this data here. If we were in class, we'd be working on this together. So we have this already completed. Again, we're checking to see if the number of cases is, what is it? Is there a difference? And so again, a two-sided test. You can see the way we wrote it. You get a two-sample t-test. The alpha is going to be 0.01, 1% level of significance. Again, that is connected back to these errors, remember we talked about, and the connection to a type 1 or type 2 error and how we change this to control for those errors. Test statistic, you may need to zoom in, or maybe I should zoom in. So we can see, we already did an example using ArtiStat. You would enter the summary statistics in there. You would get this type of data. Notice you get a test statistic, a p-value, again a low p-value, which then says since the p-value is less than alpha, we reject the null hypothesis. We're saying this is not true, and we're going to assume this is true. We have evidence, sufficient evidence to support the claim that there is a difference between North America and Europe. Again, fifth step, how was the data collected? Not clear if it was randomly collected. Is it less than 5% of the population? We have to do a little bit more investigation, but it's a question we need to know. It is large enough because n is greater than 30. And what additional questions you ask, that's up to you. And for this last example here, I did the calculations for a confidence interval. And what would it mean? Remember, we're comparing North America and Europe. Again, this is instead of a significance test or a hypothesis test. You compare them, and then we look the confidence intervals between -3,000 and to a 1 negative, which means it doesn't contain 0. Here's 0 over here, which since 0 is not part of the confidence interval, well, then we can conclude there is a difference between these two groups, right? And that North America, because the difference is negative, that means North America has a smaller average. We would assume for all cities that the average would be smaller, right? The population, because we were comparing cities in North America and Europe. But again, notice the interval 0 is not included in that.